This thing keeps, maybe what it really is this thing is not necessarily rotating. The board is just migrating that way somehow. I don't see how. Every time I look, we're cutting off this little bit here. Okay, anyhow. And it's not that anybody's messing with it, because it's moving, it's rotating at about the same rate every time. And, I don't think you all have enough precision to rotate it by the same amount every time. I mean, I'm talking about to the, 10,000th of a radian, I can tell. Look at that. Okay. Now, your key to incremental models, okay, because this comes out of the question we just got, about the continuous flow model, okay? Sipping question, but it doesn't matter what it is, okay? And we're thinking of what you can do in Excel. You calculate one step at a time, right? So for example, you calculate how big this sip is going to be, and then you use your previous calculation of how many calories there are and how many grams or whatever to figure out how many calories you're sipping, and so forth. So you set up a column for each important number, right? Now, once you get two rows set up, if you're doing it by cell reference, then you just drag it down and you have a good model. If you're using a very small sip, okay, you're going to get a very good model. Now, once you get that model, maybe you take a few sample points out of that model and try to put it into a power function or exponential function or quadratic function, whatever, right? And actually in Excel, you can just right-click and add a trend line and do any power function, any polynomial function, exponential function, whatever you want, okay? Of course, we're not trying to learn how to right-click in Excel and do that. We're trying to learn how you do those models. And of course, you know what the form of a quadratic or a power function or an exponential function is, so you can plug numbers in, right? Get your simultaneous equations, get your model. Okay? On the test, incidentally, I'll give you the rule for the logs. Okay? If you got b to the c equals d, that's the same as saying log b of d equals c. So you can solve for c. Okay? I won't expect you to know that. That's beyond the prerequisites we'd have, but it's a simple model and you've got your calculator. Okay? So that's kind of a process that you can expect to see. Is the curve exponential? Is it a power function? Okay? What is it? Okay, well, anyhow, my main, okay, well, let me stop there for a second and address a different topic.